Good morning, good afternoon, good evening, depending on where you are in the world. Welcome to our fourth quarter petroleum industry webinar. Today, we're going to talk about machine and deep learning for your modern energy enterprise. My name is Brian Boume, and I am happy to be here with your host, as your host today. And I'm excited to share, we have Mansoor Rad with us as our guest speaker, and he's going to be the one telling you all about what you can do with the Esri platform with machine learning and deep learning. So we all know GIS has been providing value in upstream, midstream, and HSE for years. You could argue that's kind of the core areas where GIS started, and we're continuing to grow in those areas. In recent years, however, we've seen huge growth in downstream and refineries with intelligent operations and digital twins, in retail with retail analytics, demographics, and kind of rethinking that retail portfolio with electrification, and in tech and innovation, where companies are going through their digitalization efforts. And these areas are drawing in more machine learning, deep learning, and AI. And the GIS platform is playing a role in that space. So today, Mansoor is going to share some examples across a few of these spaces, just to kind of give you an idea of what is possible with the tools you already have today. Next. Data science has actually been a core competency of your GIS for many, many years. ArcGIS has over 2,000 different tools that support data engineering, data visualization, data exploration, things you do as you set up your machine learning. We're continuing our work in this space. We're adding new capabilities all the time. We've integrated tools like Jupyter Notebooks, both with our desktop and our server-side environments. And we're expanding how we work with big data sets to allow you to do the type of analytics you want to do. Next. While we do this work, we're further embedding AI and ML and deep learning into the core technology, putting that information right into the Esri platform, but also in an open way that you can call out to the open data science space and share in all of those other tools and examples that are out there. And this isn't just about automating processes. This is about making your system smarter, integrating out to other platforms and other systems, and really opening up those opportunities for innovation, using those tools you already have, using the skills you're actually already bringing to the table. So that's enough of me talking about it. I'm just the host. We want to bring the expert on. And so I'd like to welcome Mansoor Rad, who's going to go into a bit of a deeper dive into some real world examples of how AI, machine learning, and deep learning are already adding value across the industry. Mansoor?
Thank you, Brian. That's good. I think we need to step back a little bit before we dive into the use cases and kind of make a differentiation between what is artificial intelligence, machine learning, and deep learning. A lot of people kind of confuse or kind of intermix the terms together, but actually there's a clear delineation between all of them. And I think this diagram here that I'm showing really present that very well. So we have been endowed with natural intelligence. And the whole point is, since actually for a very, very long time, when we've been working with machines, we've been trying to make machine become intelligent like us. Even back in the STEAM days, it was people trying to do that, stuff like that. So, of course, today we associate a lot of that with computers, but there's a very higher level concept called artificial intelligence that, again, try to make machine look like have natural intelligence and has to do with something how to do knowledge representation, or how to do planning, or how to do reasoning, or how to retain this information. Now, a way to achieve artificial intelligence is through this technique called machine learning that has a lot to do with statistics and algebra and geometry and all that stuff. And by the way, if your kids, for some of you guys that have said that, talk to them and tell them, you know, Dad and Mom, I'm never going to be able to use linear algebra or statistics or stuff like that. Guess what? Everything, at least that I learned in high school, is now coming back all over again, and I use it almost every single day. So tell them to keep at it, because guess what? They're going to end up using it if they're going to get into this AI ML techniques in here. And there's various ways to make machines using statistics and algebra and trigonometry and all that stuff happening is using supervised or unsupervised or reinforcement learning to achieve artificial intelligence through mathematics and through computers right now in here. Now, a lot of people are super excited about this new term here called reinforcement learning, which is very cool. And if you kind of looked at the game of Go by Google, or how in some cases when they were simulating like SpaceX re-entry, they were kind of using something like reinforcement learning to do that. Now, where things become super hot is in the sub topic in here in machine learning called deep learning. And deep learning is a form of machine learning that mimics how the brain works with neurons and how they're all connected to each other. And deep learning took machine learning to a whole new level. And that's what lately everybody's so excited about, because how it mimics the brain and how all these neurons are connected together. And it's achieving some amazing results in here. So I think the separation between artificial intelligence, machine learning, and deep learning is very important to understand and to separate where they are. Okay. Now, a lot of you, at least that you've been using computers or even Excel or something like that, believe it or not, have been doing artificial intelligence through machine learning without you knowing. And if we take it within the ArcGIS platform, anytime you did a classification or a prediction or a clustering, by the way, you have been doing ML and you've been doing artificial intelligence through the circle that I talked to you about. Now, again, you have not been doing deep learning because we've added this recently. But again, anytime you did like a support vector machine, or you use a random forest for classification, or whenever you did a k-mean clustering or a DB scan or a hotspot analysis, or whenever you did a regression model like GWR or OLS, and you did a forest-based regression, guess what? You have been doing machine learning and doing AI in there. Now, again, what we've done, like what Brian had said, we've added, and it's been a while right now, we've added to ArcGIS platform a way to now bring in the latest technique into deep learning to do object detection and image segmentation and tracking and other things like that. So again, we've applied these machine learning to do classification when we have land covers and we want to be able to take typically a raster and be able to classify each one of them on what kind of pixels they are. And again, you as a human, when you look at the picture on the left, you're very good at knowing that this is a building, this is a road, this is a tree. And the kind of idea for doing that is using machine learning and deep learning to do that. Now, you've been able to do that before using forest-based classification or support vector machine, but using deep learning, this is so much more powerful for doing that. Same thing with the regression. You've been doing machine learning through regression whenever you did a GWR or a NBK or an OLS or a forest-based regression. Again, now through deep learning, you can do regression technique, again, depending on what you wanted to do with that. And of course, clustering, one of my favorite ways of doing things, because there's so many unknowns, but you can see the patterns in the data and you wanted them to come out automatically for you, right? And so using clustering technique, you can, with space and time, by the way, and additional attributes. So this is multi-dimensional patterns of life, behaviors and stuff like that starting to show up. And again, as I keep saying, anytime you did pixel segmentation, hotspot analysis, or a clustering, you've been doing AI and ML. Again, as I keep saying, what's exciting is the deep learning, and that's what all of you are here is for, that deep learning and neural network. Now, today, a lot of it has been applied on, I would say 80% of the projects that we work on has a lot to do with imagery. I don't know if you know, I am in professional services. I've been with Esri 28 years. And I've seen all kind of things happening. And this is where I get so excited about things right now is this latest project. 80% of the project that I work on right now, when it comes down to deep learning, a lot of it has to do with imagery. But we've been able to work on vector data, audio data, video data. And I'm going to be showing you some of these examples in here. We did it for pixel classification, like, for example, for surface classification. We did it, like, for example, there was a project in Dubai where we did palm tree detection. By the way, the palm tree detection, when we did it, was from drones. So you have various level of resolution to be able to do that. Of course, to be able to detect the palm, you have to have very good resolution for that. Like a drone was perfect for that scenario. Building footprint extraction is a huge project where we're working with cities to help out with that. And of course, when it comes down to disaster responses, be able to detect and help, for example, FEMA with detecting from aerial pictures damage and turning those damaged location into points. Then you pass it to network analysts in such a way that you can come up with the best sequence to service these places or detect a bad damaged road as an impedance and how you get around it. All these things come in to help us out with this equation in here. Again, as I keep saying, you could have done this before, right? But using deep learning today, it's becoming such a more powerful way of doing things like that. So before the ArcGIS platform, you had to come up with your own way to do data fusion and data integration. Data is in various places, in various sources, like you have the data potentially in an S3 bucket if you're in Amazon, or in a blob storage, just on Azure, or in actually disk, or some of the labeled data are in various databases. For example, they could be in a PostGIS database, or they could be in a shapefile or geodatabase. And again, it doesn't matter what the medium and what the source is. One of the things about the ArcGIS platform is you can fuse all this information together and bring it in. Now, in the case of a imagery detection, the process is actually getting first access to the imagery, and you can do it through ArcGIS Online, or you can do it through your local disk drive, again, or a hybrid scenario, which is very interesting. Again, you need to label the data. Again, where the source of the labeled data can come from various places, from a database, from a shapefile, from a geodatabase, from a snowflake, or from whatever it is, it doesn't matter. You can bring all these things in here, or we provide huge tools right now to do it by hand, to do the labeling by hand, because a lot of the data sometimes we look at does not have existing data. And you can now create a workflow where now you can decimate that work to multiple people in such a way that they can do the labeling. So the image fusion, the data labeling, and then preparing the data, all that can be done in ArcGIS. And again, you can train the data now within ArcGIS. In this example here, for example, I'm shifting to show you Notebook, and you're saying, wait a minute, why is Notebook showing here? Like Brian said, we've added these technologies. So again, you do not need to, you can stay where you are. Now, by the way, if you wanna leave the platform and do it, you can. I'm not saying you do not, you're stuck in this whole thing in there. You can use various scenarios there. But a lot of people like to stay in one place and they can share. For example, I like to put the Notebook and the map simultaneously by creating two separate tabs, and I can view what's going on in here. So for me, starting up a Notebook and the Pro, in which way I can look at the data and go back through the process, helps me a lot in there. And at the same time, sometimes I use the in the cloud platforms like SageMaker or other Kubernetes-based environments to do that. So I trained the model. Of course, a lot of the time, by the way, they need GPUs, those model training, because, well, these are very complex operations. And sometimes they might take up to a week if I'm doing like a point CNN, I'm doing LiDAR data. And again, by the way, like I was telling you here, it's not just imagery. We can work on vector and LiDAR and audio and all kind of stuff like that. And there's various models to do that. Once you have the model trained, you can now use it to start, for example, in this particular case, detect oil pads. In this example here that I'm showing you, it was detecting oil pad, and then you can compare, for example, where one was registered or not, where there's a new one or something like that from there. And of course, the biggest thing about that is the post-analysis. Again, when I talk about data fusion, it's not just on the beginning of the process, but at the end of the process too. You have these detected objects, right? You classify them and all that stuff. But what do you want to do with it? You want to fuse it with other things. And this is where the 300 tools and plus more than 300 tools that Brian talked about, come in to help you with fusing all this information together and then producing it like into an operational dashboard, continuously seeing the updates and or pushing it to mobile devices or to field operation. All these things happening, and again, you can come back to the loop over and over again because you have more data. You can label more. You can take the model that you existing have, train it further using transfer learning, and keep on going over and over again. Okay. And something very important that people do not understand, especially when it comes down to deep learning, is this is not a one-time and you're done with this whole thing. You need to come back to it if you want, kind of like a child. The more you teach it, the better it learns, and it gets better and better and better. I deeply believe repetition makes perfection, and it's kind of the same process in here by giving it better labels, giving it better imagery, having better models. And by the way, we are constantly updating our models and what we offer you. And if you want to use your own, you can. There's no problem for doing that. But again, it's what you do with it at the end, those objects that were detected, that makes sense out of it, and the fusion of those two things, and then how you present it in various ways, it makes it very, what I call, expressive and very powerful for doing that. So now let me talk to you. As I said, I'm in professional services. This is a kind of boots on the ground and what we've been doing lately in these models, in these things in here. A while back, we looked at insulators to detect broken or contaminated or flashed contaminators from insulators on power lines. Now, again, the classic way is to have a person flying it in, and he or she has a binocular that are very special. They look at the particular image, and from that image, they can detect what's going on in here. And so they have to go back and take all the images and then classifying them by hand. Well, today you can do that so much more efficiently, rather, for example, from drones and all these. Now, once you have enough information about it, you can fly up, for example, the drone. It will detect all these things and bring it back in. And again, as I keep saying to you, what's interesting in this scenario in here is not just the detection of a broken or a flash or contaminated insulator, but once you have the accumulation of all these guys, suddenly these patterns of life starting to appear. Again, you have the location of the broken insulator, but again, by looking at a statistical trending over time of all what's happening to that insulator and potentially to its neighbors, that's what makes it exciting. And that's where you can see the patterns of life appearing. And now you can come up with potential hypotheses, what's going on. And using geostatistics, you can validate through all these things in here, which is very nice. Okay. Another application here is road crack detections. The DoD has a very well way of organizing the classification of road cracks, right? So you have a crack, it's a linear crack, it's a longitudinal or lateral and all that stuff. And they have these various classifications. If you look at that scenario, ladies and gentlemen, it makes sense to make it, you know what? Why can't we do it through deep learning for doing that? So exactly this is what we did. Now, what's exciting about this project is you do not need expensive machines to do that, ladies and gentlemen. Right? In this example, we ended up using a GoPro camera on the dashboard of a utility vehicle. And it drove down a particular road, and then we brought in the SME, and the SME is the one that basically went in frame through frame, labeled the data based on his or her expertise in the matter. And by doing that, we were able to then train a model to do that. Now remember, a video, ladies and gentlemen, is nothing but a sequence of images. And so you can imagine, yes, it is a little bit painful to train, to label the data, and once it's trained, to then push it out. But the beauty about it is, like I was telling you, oh, I need a drone or other expensive scenario in there. In this scenario in here, we ended up using inexpensive hardware like what's his name, like a GoPro to do that. Of course, the network has to slow down on me because I'm doing a live demo. Is that right? Okay, so we're going to continue on that one. But again, what do you do with this information? So once the cracks have been detected, well, again, you turn that into a feature class, and now you can put that and represent it on a map, and then you can then have a kind of an overall dashboard experience about it. Now, for example, imagine you can come up with correlation with winter operations. So we're working a lot right now with DOTs that have winter operation. And because of the, for example, smart snapping application of GPS breadcrumb to roads, we can now detect where exactly somebody was, for example, dispensing snow or dispensing salt or stuff like that. If we can come up with a correlation between winter operation and summer operation where they're patching holes, we can come up for next year prediction model of how to better predict the cracks and what to do for operations time. Okay. So that's very, very cool. Now, in oil and gas, this is something that I do all the time with a lot of oil and gas companies, which is what I call lease road detection and digitization. So as you can imagine, there's a lot of lease wells all over the place, and there's a lot of lease roads to go into them. The problem is if you get the standard roads that come in from here or OpenStreetMap or stuff like that, you have the primary road, secondary road, tertiary road, no problem. But what is missing always are the lease road to get to there. So as you know, I need a full sequence. I need a full digitized road here to come up with, for example, an inspection route in such a way, what is the optimal way for me to go from one well to another well for inspection or various other things? Well, if I don't have the network underneath it, the roads underneath it, well, then I cannot come up with a correct sequencing to do that. However, a lot of you guys have already pre-existing GPS breadcrumb to these locations in here. So if we accumulate enough GPS breadcrumb, and this is where big data comes in to do that, right? And again, not all the GPS breadcrumb are nicely sequential or stuff like that. They can come from various trips to the place in here. But if I accumulate enough, suddenly I can see a pattern and I can now do something about it. Now, again, how do we gonna be able to turn those points into lines in here? And this is where I wanna show you something very interesting. Here, we use something called unsupervised mode of learning, where giving a set of points, we wanna mutate a line in such a way that it maps to the underlying points. And again, the rule here is break a line, add an edge, break a line, add an edge. And if we let it self-organize itself, right? If we let it self-organize itself, let me do that again one more time for you guys. If I let it self-organize itself, it will figure out, it will map the points to a line, and suddenly now I can join the derivative line back to the network, and now I have a fully connected network to the cluster. Isn't that cool? To the network. Isn't that neat? I love this thing. When I saw it learning by itself and figuring it out all this by itself, I almost fell off the floor. It was so cool. And by the way, you do that in parallel and distributed, like for example, on a Kubernetes cluster, it will all these do all in sequencing. So you're not doing this sequentially, you're doing that all in parallel, and you can basically solve a lot of things. We did this here in the US tremendously, in the Middle East, of course, tremendously, and we were able to see some amazing, amazing results from that scenario in here, okay? Let me go back to the presentation. Okay, where is my presentation? I'm sorry about that. Here we go. Okay, and so again, as I said, we turned it back into a beautiful operation, fully connected network, and now we can do something with it. So, by the way, we can do also the same thing from images, right? So again, you as a human, when you look at the overhead imagery like that, you can say, can we do that? And guess what? Yes, you can do that. Now, This model, you do not have to build that model yourself. We at Esri already have pre-existing models that you train. Yes, in the previous example, I had the whole self-organizing way of doing it, which is kind of cool because I'm in PS and I can do that kind of stuff. But I realized that this is a pattern that has to be done over and over again. Guess what? We ended up coming up with a model that detected roads, and we ended up publishing, and using what we call transfer learning, we were able to teach it the local scenario. Like, for example, what's happening in the Middle East is a little bit different than what's happening in Texas, right? So we're able to teach it those local scenario, those local tendencies, and it will come up with a beautiful, beautiful representation. So again, this one taking raw imagery and turning it into a line network, same story, and now you can pass it to network analysts and you can do operation on it. Again, ladies and gentlemen, remember the deep learning is very cool, right? But it is what you do with the derivative of the deep learning that is very exciting about the whole thing in there. And that's what is so cool about it, is the downstream analytics, the data fusion, the data orchestration that you can do all that with that. A last example that I'm going to talk to you guys about is oil slick detection and ocean surfaces. And this is actually a very interesting use case that came out where, and it's a big problem in the Middle East and with some ports and stuff like that. What happened is tankers come in. Before they go into the harbor, to the port, they end up stopping offshore, and guess what they do? They wash out their tanks, right? This is a use case that's very well known, and all this pollution ends up spilling out in the ocean and stuff like that. Now, this is a big, big, big problem because a lot of people are accusing some government or some agencies like you polluting and stuff like that. Actually, turn out it's not there. There's all these guys that are doing these nefarious operation, and for example, washing out their tanks and flushing it, and then before they're going in to clean it, right? And so in this particular example, we end up using SARs in here because SAR data is independent of cloud and day of night, or day or night. By the way, those washing operations are happening at night, by the way, right? So SAR can see through this. But now you're telling me, how do we do this? Well, guess what? By taking the SAR image, this one band image in here, bringing weather information, bringing wind information, which is very important in this oil slick detection, bringing, for example, also potentially waves, height and stuff like that from buoys. We can integrate all that, and we taught a model on how to detect those oil slicks from the SAR data. Now, again, like I keep saying, the exciting part about this whole thing is not just the detection of the, excuse me, of the oil slicks, but what you do with the derivative of this data, which is in this particular case, you now can tie up to the AIS data, and through big data analytics, you can now find out at that time of day, at that most likely AIS ship that AIS broadcast that was near it, and now you can go on with your investigation with that process in here. Okay, so some very, very cool analytics here that we've done, and we are it's very cool to see it in action. A lot of these things, again, like I keep saying, is there is the deep learning is cool, right? Which is neat. You can do that and you can train it, and we have models, and I'm going to show you some things in here. But again, it is the downstream analytics, the data orchestration, the data fusion, right? That makes it more actionable, as you can see it, okay? So key takeaway that I want to talk to you guys about is with the ArcGIS platform, you can do this on any platform, right? You can do it in AWS, Azure, or IBM. It doesn't matter which platform you're in, of course, on-premise. There's a lot of tools for machine learning. And by the way, like I told you, You've been doing machine learning for a long time, ladies and gentlemen. For a lot of people that have been, even a simple regression model like an OLS is in machine learning. So that means what you've been doing artificial intelligence. Why people are excited about artificial intelligence now is because that little inner circle, which is what deep learning. Well, guess what? Now deep learning is part of the tool. I'm going to show you some pre-trained model. Again, you do not have to build these models from scratch. We have done some of the work for you guys. Use them, and I'm going to show you some URLs to these places in here. And again, if you're a programmer, you can use various APIs, right? So like R, Python, Java, .NET. A lot of this stuff, by the way, like I showed you, can be done in Pro from the desktop tool. But if you want to drop down and use your own MXNet, PyTorch, TensorFlow, all that stuff, guess what? You have to do that. And of course, connectivity, data integration is very important. Bringing data from an S3 bucket, from Snowflake, from Microsoft Cosmos, from your own local data is possible. And again, this data fusion, data integration is so important to the process in here. Now, I'm going to come back to this in here. If some of you guys want to take a screenshot of this, by the way, we're going to share all this. So I'm going to switch to some of my tabs in here that I have ready for you that you guys can see, right? So for example, there is a beautiful GeoAI blog post that talks about how exactly we did it, right? All the details, nitty-gritty, and even some coding in here. If you want the notebook coding is all talked about in here. I highly, for people that are interested in going deep into it, shows it. This is a oil pad detection for some of you guys, but some of you are, all of you are super smart. You can figure out what we can be doing next. So again, a full detailed description. This is, we updated in February 2021, the pre-trained models that I keep telling you guys about. So for example, there is no reason for you to guys build your own building footprint model. You can already start with one. You can download it, start it up in ArcGIS Pro or server or on the cloud to get going for that one in here. So we use this one as the starting point for a lot of places. And for example, this one is my favorite now that I'm using it tremendously. Again, this is the one I used for Texas, but again, I took that model, pre-trained it for somewhere in the Middle East, and I was able to use that in the Middle East for the same purpose in here, and works out beautifully. There's also land cover classification, and there is various other models in here. I don't know why somebody's interested in shipwreck, but we have it for you in here. Enjoy it. And of course, license plate blurring. Again, data does not have to be from satellites. It can be from oblique imagery, by the way. We have a lot of example on that too. Again, the data does not have to be static. It can come from video, multimedia. All that is all in here, so check it out. There's a lot of example in here. Start up with the GeoAI blog in here. Again, the landing page, the GeoAI GitHub, GeoAI, plenty of resources. And of course, the oil and gas is right here for you guys. Take a look at it, lots of resources. And of course, if you wanna do it, we have various videos, tutorials, sample notebooks. All these are available for all of you guys to have fun with, okay? And we keep on blogging about it every once in a while on how to do it. Like, for example, this is the latest one here at CycleGAN, which is very cool. 3D building extraction. There's the huge LiDAR data. I've been doing, me again, as professional services, I've been doing lots of LiDAR work in here. So yeah, very cool stuff in here to do that, okay? So with that in mind, let's finish up the presentation here. Back to you, Brian.
Thank you, Mansour. It's always great to hear you talk. You're so passionate about it, and you get so worked up about what the art of the possible is. So hopefully you've energized a few folks in the audience to see what's possible. And it's just, yeah, great examples So we've talked about several of
Right.
these application areas that you can see on the screen. What we want to do now is open up for Q&A. So we've got folks in the background that are helping to moderate that Q&A. So please get your questions put in through the tool there, and we'll start asking from the list we have. And the first question that comes up, there's actually two questions here that are kind of related. One of them is, can users use the base maps that are already in ArcGIS Pro or in their server to do some of this detection on? Are those high enough resolution? And if not, what is sort of the kind of minimum level of resolution you would need for these models to actually work? And the question was mostly about wells and pads.
Right. Do you want to take this, or do you want me to take it, Brian?
Oh, this one's yours.
Okay. So you have to be very careful about the usage of base maps. When it comes down to ArcGIS Online, the answer, unfortunately, is no, because the license term that we have licensed to the usage of these base map or for visual, they were not intended to be used for training machine learning model. I don't mean to go lawyer on you, but you have to be very careful, especially for corporation like you, that some of you guys in there, the term of use of the images that you're going to be going into. Okay, and again, you can contact somebody like Airbus or what's some of the other companies, Brian, help me out here, Maxar or some of the other guys, and
Yep.
they will set up terms for you guys on using these images for deep learning. So please, so I'll tell you again, for ArcGIS Online, unfortunately, the term of use with our partner are not intended for machine learning. They're only for visual. Please contact, and we can help you, by the way, facilitate this with some of our, because we have business relations with these, to give you what you're looking for. Now, as it comes down to resolution, it depends on the problem that you're trying to solve, right? So for example, if you remember the PALM model, even from a Maxar scenario in there, if you don't have enough resolution, you're not going to be able to pick up, for example, a palm tree on a 50 centimeter resolution. So in, for example, when we did the palm tree detection, a drone at 0.1 was a much better solution for that, right? Now, again, for example, I was working with a government agency, though they had drone data for that particular scenario because it was a 10 centimeter resolution, but the object that they were trying to detect was so big that I had to downsample it in such a way that I get the context of what I'm looking for to be able to detect it. So again, resolution is always proportional to the use case that you're going after. And if you have any questions about it, we can help you out with that. So not always the highest resolution is the best to your use case. Again, I don't mean to go lawyer on you, but please check the term of use of your base maps to when it comes down to extraction for deep learning. Okay. Next question, Brian.
Yeah, lead on to that question for you as well.
Yeah.
You mentioned SAR data in one of your demos. What about the data, the public source data from Sentinel program or the Landsat program? Are some of those data sets good to use for this technique?
Yes, you can. Again, double check the license term. But if, again, depending on your use case, some of these publicly available data are good enough to do that. Now, in the SAR data that we talked about, I was working with, I remember with Airbus, I remember on this one, and there's another company, I forgot the name, and they had massive labeled data. So I was very lucky. Now, in that data set, they were able to, we were able to work with them, and they had the correct term of use to be able to use that data for deep learning, and there was no problem there. Okay, so again, use case, term of use. Again, I don't mean to go lawyer on you, but it's it's very important, that thing. Next question.
So the next question is about live data. So the question is, do you have any examples posted with some of the resource links you shared that are associated with real-time data feeds, like something that the user may see from a Pi historian?
Correct. So I did not show it in here, but we have actually in our resources, you look at it for live video streams where we can do live tracking of assets and various other things like that. And so again, using video feeds, we can now tap into and do object tracking, object detection. It's again, the technology, ladies and gentlemen, to do object detection or object segmentation is democratized. What you do with it is more exciting. Like, so for example, when we're able to do detection of video or tracking objects or object segmentation, we did it at an intersection, which turned that information into a hotspot analysis on an operational dashboard. So yes, it's very exciting to see the outline of a person or of a car or of a truck or stuff like that. But the statistics that comes out of it, the count statistics that comes out of it, how many cars per hour, what direction they're going at, all these things, this is what I get more excited about it. And then fusing it with other data that are coming in there, that is the derivative to give you what I call expressive application and actionable information.
So our next question here, I can take this one. It's, could you use similar methods or techniques on methane emissions or some of the emissions monitoring our industry is now trying to do, looking for fugitive emissions and or doing emissions reporting? And the answer there is yes. It's similar data, it's similar techniques. You might be using a different sensor, whether it's terrestrial-based sensor like cameras or off of vehicles or drones, or whether you're using fixed wing, et cetera. So depending on the source of the data, obviously you might use a different technique, but the concept is the same. And I'll actually direct you to the European PUG that we just held. We'll be publishing those sessions here shortly. And there was a great presentation there called Project Zeus, where they were using multiple levels from satellite base all the way down to ground sensors and processing the data for that exact purpose. So I encourage you to look that up as that gets posted.
So follow up on this one. I don't mean to interrupt you, Brian. Follow up on this one. Again, like a keyword that Brian said, which is data integration, right? The techniques to do the deep learning is always the same, right? It's a certain input, some bands, typically when we're doing it with raster and stuff like that. It is what you bring in the data and how you mutate it, right? To come up with the normalized, quote unquote, normalized input, and what comes out of it is always the same. As you know, 80, potentially 90% of your work is what I call data janitorial, right? You're not a data scientist, you're a data janitor. Why? Because you're cleaning, mutating, adjusting the data. That is 90% of the work. It's that data orchestration, data fusion, data integration. That is 90% of the work. Then finally you come up with, okay, I have enough good training data to go into a model. And again, what you do, what comes out of it is so important, right? So the techniques is always the same. It is what data sources you have that's important. You adjusting it, cleaning it, fusing it, that makes the difference. And again, depending, like what Brian's saying here, yes, this and that data source are much better. Like for example, the SARs here, it was not just SAR, it was SAR and temperature and wind data. All these together from disparate data sources that help us out with the oil slick detection. Same thing with the methane.
Great. So I think you have energized a few people, because I have a couple of questions here about what tools do I need? What extra licenses are required for me to start doing this today?
Yeah, you don't need anything. You download ArcGIS and you're up and running. The biggest thing is the data, as I keep telling you about. Please look at some of these samples here that I'm showing, right? How we did it if you want a Jupyter notebook, or look at some of the other tutorials that I was telling you about in here. So quick start, how you're gonna go a deep dive, sample notebooks, we have plenty of sessions that we talked about. So take a look at those. Again, you do not need to be a programmer. This is the fallacy about the whole thing. Again, you'd need to know a little bit of what's going on. So don't assume that, oh, you push a couple of buttons and Bob's your uncle. Far from reality. The samples are good, but having that already experience of a little bit of knowledge of will help a lot in, for example, tuning the model, canning various scenario in there. And cheap plug-in here, we do. I'm in PS, so I have to sell myself as professional. We do help people like you guys to get to know these intricate details and stuff like that. So get started here, right? And if you want more help, handsome me, in all modesty, coming to help you.
So here's another help question for you. So if my company has corporate data warehouses, something like a Snowflake or Teradata, Azure, can ArcGIS integrate with these to start doing machine learning and AI?
Definitely. So we use that. We do that all the time. As you know, we have the data connectivity. Typically, when what you're talking to me, that person that asked that question, typically this looks like this has vector data that's sitting in the Snowflake or stuff like that. Or in some of them, they can put in the blob for doing that. You can do that because of how ArcGIS connects to various data sources, raster, vector, typically, right? So you can bring that in, because for us, a data source is a data source. But then we can then go through the process, like I told you in here. Let me go back to my presentation in here, the previous one, which is key, this part here, right? So imagery can come from Esri or come a blob, it doesn't matter. Labeling, the polygons in here can come from any database, shapefile, Snowflake, whatever it is. And then you prepare the data using the tool, training it. You want to train it in ArcGIS or outside ArcGIS, your decision, and the model that comes out of it, what you want to do with it. Again, your decision in here, and then fuse it with other post analytics. Again, your decision. Again, I'm showing you imagery here as an example. The fact that the imagery is coming from various data sources, the labeling is coming from various data sources, is possible through the ArcGIS platform. And again, guess what? If it's not available, drop down. We can show you how through a Jupyter Notebook or Python. Typically, 90% of our people that want to do kind of custom stuff, if they don't want it, it's Python. It's easy to learn, and we get going from there together. Okay, I hope that helps.
Yep. So the next question here is an easy one. I like taking the easy ones, so I'll get this one.
Okay.
The next question is, will we make this webinar available as a recording? And the answer there is yes. We post all of our previous webinars on esri.com/petroleum/events. So you can find the previous webinars we've done. We also try to list the next webinar coming there. So I definitely encourage you to pick this up there. Should be available within 7 to 10 days. So next question is a harder one. So back to you, Mansoor. So just to clarify, we need to label the training imagery so the model knows what to look for, i.e. like a gas treating facility. Can you talk a little more about that training process?
The training process, okay. So the labeling is literally the process of typically putting bounding boxes, drawing polygons around the image, in the image of the things that you as a human can recognize. This is fundamental here, ladies and gentlemen, is if you as a human, when you look at the picture and you can identify the thing that you're looking for, then great. Now, the key here is how many of those labels you want to do. And of course, the more, the better. Now, when we have the label and we have the raw imagery, we prepare through a process we call export training for deep learning, which now basically breaks up the problem into little chunks in here. The training is basically taking that data that you prepared and dividing it into what we call training and validation set. And here in ArcGIS, you have the option of selecting the model that you want to be training on. And we provide you various models. So let's say, for example, that you want to do a pixel segmentation where you want to be able to do classify a pixel of, like, let's say, a road versus no road, or lease road versus no lease road. In here, we have various models. We can give you, like, for example, a UNet, we can give you a deep lab, we can give you a PSP. These are what we call the head of the model itself. Then we let you put back ends like a ResNet 34, ResNet 50, or a Inception. You can compose that through the drop-down model, through the drop-down in here, and then you can specify the training time, the epoch, and we'll let you control a little bit of the errors, like if you want to do a focal loss or something like that, and you train and you let it train. You can do that via the UI, or you can do it in a Jupyter notebook to do that. So we find people doing that. And again, if you want to do object detection, we have YOLO, we have SSD, same thing. These are typically the head of the model, and you can select the backbone, a ResNet, an Inception, whatever it is. You put them again through configuration, and you train the model. We keep tab. If you, for example, are into this and you want to bring up TensorBoard to check out all the curves, you can do that too. And what we give you at the end is we give you the metric of the model. And the metric of the model, we give you the recall, the precision, the accuracy per class. We give you the confusion matrix. And this is how, by you looking, depending on your problem, on recall or precision, looking at that confusion metric, you will decide, I need to go back, retune, readjust for doing that. We don't have AutoML. We don't have like auto tuners or stuff like that. However, can you use our API if you're familiar with like something like Optuna or SageMaker or something like that? Definitely. And again, this is a little bit more of an advanced topic. We can talk about it if you want. Shoot me an email for doing that. Again, once a model is produced, you can then now you can apply it at massive scale. You can use raster analytics. We've done it, like for example, for the JAKE, we end up the Joint Artificial Intelligence Center for Disaster Recovery. We end up spinning up 100 GPU cluster for FEMA to be able to solve their requirement of doing the whole East Coast in under an hour. Okay, now again, you're telling me why that was crazy, because that was their requirement and that's what they wanted to do. And we were able to do that through Kubernetes. So we took the model, we broke it up horizontally under a Kubernetes cluster, took the data from Esri and presented it. And so I hope that gave you the full end-to-end gamma and detail about what I was, the product.
No, that was great, Mansour.
Brian?
Yep, I have two more questions in that same frame. One of them is around unsupervised learning. Is there some options for unsupervised learning in the Esri stack? And then another around classifying polygons by attribute within the model. So
okay,
you want to take those two?
So yeah, definitely. The first one is fairly straightforward. By the way, if you want to do unsupervised mode of learning, there is no reason right now for deep learning. There is a lot of tools for it. Again, depending on what you're doing. Typically unsupervised learning is what's his name? Classification problem that you can help out with that. So typically it's a classification problem. We have HScan, DBScan, optics, K-mean, and all that stuff like that. Now, there are some things we're working on, and there's a blog post that coming in that we submitted to NeurIPS, by the way, where we can do self-supervision, by the way, which is very cool. So rather than you digitizing the whole thing, one of our colleagues has submitted a NeurIPS paper to let it self-organize the supervision of the training data. Very cool topic. As you know, a lot of people are talking about that right now. So we're waiting for the acceptance of the paper, and then we can talk about it. So we're doing some, by the way, in the back end, a lot of R&D work that eventually will go into the product in here. But today, as far as machine learning, lots of unsupervised mode of learning that you can have. Nothing yet in deep learning right now, but definitely a lot in machine learning. And if you remember the circle I talked about. What was the second question, Brian? I forgot. Forgive me.
It was around classifying polygons by attribute within the model. Examples like buildings, trees, or cars.
Yes. So again, very good. So when you label the data, the labeling is proportional to the attribute that you want to be using it for, right? So when you label the polygon, and you want to generate these training data that we keep talking about, you have to select the attribute that is reflecting to the polygon that you are trying to learn to teach the model with. So it is a drop-down option for you to select from what to train, what this polygon represent. If you want the polygon to represent multiple things, you can, but when you train it, you can tell it what is the classification for it. And of course, by the way, it's not binary, this classification, it's a background or this thing. It is a multi-classifier, so you will put that in there and it will learn the process. Now you have to be very careful here, okay? Because a lot of people think like humans when they're doing training. So for example, I was working on this project, again, the lease road detection. It was a paved, unpaved leased road, right? And I was kind of teaching it on this data that was paved, and suddenly parking lots were appearing, right? Turn out that it learned the concept of asphalt, not the concept of asphalted road, road that has with asphalt, right? So it ended up labeling paved parking lots. So though I labeled the roads and I was thinking like a human, right? Because that's a road, that's a parking lot. There was no reason for that. It ended up learning the concept of asphalt versus non-asphalt. And in my prediction, a parking lot was appearing too. So guess what? I had to go back, tell it that this is a paved parking lot, this is a paved road, to make a distinction, because it's artificial, right, ladies and gentlemen? And retrain the model for it to learn the concept of paved road, not just as something that is just paved. You see what I'm saying? So again, you come in with this human knowledge of like these little nuances that we as humans will take for granted. Well, guess what? That's why it's called artificial intelligence. You have to teach it all these things, okay? And guess what? Like I told you, ladies and gentlemen, this is an iterative process. It's not you push a button and magic. You have to go through it. Like in the example that I just told you, you think you labeled it correctly, but once the model learned, it's learning something that you did not expect, and then you have to step back and look at it and understand what's going on. Okay, so very cool, very exciting. And again, remember to your kids, stay in school, learn your math. It's gonna come and make you look cool like me and modest.
Thank you, Mansour. What a great set of
All
topics, great set of examples, and really appreciate the audience and your questions. I think we made it through all of them, so wonderful for those. And really appreciate you joining us today. You can look for the recording in just a few days. Thank you for your time. Everyone have a great day.
All right. Bye, everybody, and stay in school.